So this is the alternative to practical paper 6 physics. And the first topic, there are subtopics like time, length, time, the balancing experiments are there, light experiments. So it's divided into subtopic. The first topic is the time period. These are the key notes, the key points which you should remember. When you start this, you should go through the key points first and then you will start the exercise. So question 1 is actually related to planning experiment. So in this question, a student is investigating the time for a metal ball to stop moving after it being released on a curved track. So what student did, student released a metal ball on a curved track. So it will move towards the other side and then it will return back and eventually it will stop by repeating its motion for several times, and eventually it will stop at the mean position. The following apparatus is available. We have a selection of a metal ball of different masses, the flexible track, the clamp to hold the track, a stopwatch, a tape measure, the meter rule. The student can also use other apparatus and material that are usually available in the school lab. Whenever you're writing an experiment in paper 6, you should try to answer the points rather than just write a paragraph. So here, plan an experiment to investigate a factor that affects the time for a metal ball to stop moving after it being released on a curved track. So student is investigating any factor. They did not mention which factor. So can you identify any factor which can affect the time it will take to stop? A factor which may affect the time it will take to stop. Yeah.
Mass.
The mass of the ball. Yeah, that can be one factor which can affect the time it will take to stop. What else? Size of the ball can be air resistance, the curvature of the track, the length of the track. So many factors are there which can affect the time it will take to stop. So the first part, state how you would expect the ball to move. How will you expect the ball to move? How the ball will move if you have doing this experiment and you release a ball on a circular track, and what do you expect how the ball will move? So back and forth, to and fro, it will move. It will goes forward and backward several times, eventually it stop. So the first part, when we write the answer for the first one, and whenever you're writing an answer, you answer the point. So what is the first point? State how you would expect the ball to move. So how you expect the ball to move? The ball will move back and forth like a pendulum. Eventually it will stop. So the first point, it will move back and forth and to or fro several times and stop at the mean position or the center position. That is what we expect this ball. That's how the ball will continue its motion. The next one, explain how would you carry out this investigation? Like how we will do this experiment. Practically, if they give you this apparatus and they say plan an experiment to find how much time the ball will take to stop. So how you will plan this experiment or what will be your procedure? So what we simply do, we'll release a ball from a certain position and we'll start the timer or a stopwatch. So we will, here we just have to mention the procedure. We don't have to change the variable, anything. We just have to mention a procedure, so how it can be done. So we'll release the ball from a certain position and start the timer. And record the time for the ball to stop, and then repeat the experiment. So the second point, when we write, we will release the ball from certain point and record the time for the ball to stop completely. And then whenever you're doing the experiment, you should repeat. So that is the second point. State which variable you would keep constant and which variable you will change. So this is the open response question, like only one you have to keep change and the rest you have to keep constant. First, what are the variable we should keep constant or same, and which one we will investigate? So which variable we should keep constant? The length of a track, that's good. The position, the point where the ball is released. So for this experiment, the variable should be constant. The length of the track and the position from which the ball is dropped or released. These are the two variables which we should keep constant. And which variable we will change? We'll change
Sizes of the balls.
your size of the ball. Any one you can mention. Like we can use different size balls, or you can also mention mass of a ball. And if you mention, like, it's up to you. If you mention like you're investigating how the length can affect the time it will take to stop, so you should keep the position on the triangle or the size of the ball same. So if you mention what you mention for constant, you cannot mention for change, and what you mention for change, you cannot mention for constant. Then draw a table or tables with a column heading to show how you display your readings. In exam, you don't have to write any numbers, you just have to show like how because you're changing the size of the ball. So we'll draw a table. The first one, we have the size of the ball. And the second one, the time it will take to stop. So size, usually like a diameter is there, normally in like millimeter or centimeter. So whenever you draw a table, table should be with a column heading. So size and then slash the unit, example, millimeter or centimeter. And then time, you can use letter T and then slash the unit is second. You don't have to write any numbers in the table. The table you have to draw, yeah, it should always be drawn with pencil, where you always use the pencil. And the second thing, there's no blank page available, so you have to draw a table with the space available here on the same. So this is a table which we will draw. The next, explain how would you use your reading to reach a conclusion. So how we can use the readings to reach the conclusion or draw a conclusion. So what we can do, we can draw a graph between size and time, or we can plot a graph as we are changing, like we are changing a size and recording how much time it will take. So you can just mention here, you don't have to draw a graph, you can mention plot a graph or sketch a graph. It should be plotting because it's an experiment. So plot a graph between size and the time. And normally on x-axis, we have independent variable, like the variable which does not depend on other. We are changing the size. When we change the size, the time will change. So size should be there on x-axis and time should be there on y-axis, because when we change the size, the time will change. So size is independent, time is dependent. Yeah, if the question is in change in mass you are making, so then it should be it should be in gram or kilogram. Normally in gram is appropriate, not in kilogram. You can mention the mass, Ahmed, you can mention the mass, you can mention the size. Both are acceptable. Because it is obvious that if you have different masses, then definitely they will have different size as well. So you can mention the size, you can mention the mass, it won't make difference. So we just have to make, if you are making a graph, just label the axis, the x-axis and y-axis, but don't draw anything. You don't have to draw any shape of the graph. You just label the axis, the x-axis and the y-axis. So this was question 1 from the exercise ATP time period topic.